So hi, I'm just going to cover something pretty standard. So you'll be expected using de Moivre's theorem and further maths to calculate the roots of unity. Obviously, we know that the square root of 1 is 1, but on the complex plane there are multiple nth roots of unity. So I'm literally just going to find out the fifth root of, or the five fifth roots of unity. So what I'm going to write down first of all is z to the power of 5, whatever that happens to be, is just equal to 1. Now, obviously, you would normally just take the fifth root of that and end up with 1, but on the complex plane, ironically, things are slightly more complex. So I'm going to write 1 as cos 0 plus I sine 0 on the Argand diagram. So obviously, if we were to have our imaginary and our real axes, that would just put one right where you expect it on the real axis with no complex or no imaginary component. So what I'm now going to do is write z to the 5 equals cos theta plus I sine, cos 0 plus I sine 0, as we have up here. And we can then write down, obviously we're not going to add 0 to anything because it won't make a difference, but we can write down 2n pi plus I sine 2n pi. Because of the symmetry, the 360 degree or 2 pi symmetry of the complex plane, we're going to have where n is an integer between 0 and 4, to give our 5 roots. We're going to have 5 equally spaced roots around our Argand diagram. So what we can now do using de Moivre's theorem, or rather that'll be our next step, is I'm going to write cos 2n pi plus I sine 2n pi. I almost wrote a 2 pi there, all to the power of 1 over 5. So we're effectively taking the fifth root of both sides, and that way we're going to end up the z value, the fifth roots of unity we want. And now by using de Moivre's theorem, we can multiply the angle through by 1/5. So we end up with cos 2n pi over 5 plus I sine 2n pi over 5. So we have our 5 different values of n, starting at 0. That will give us our first root, which is in fact 1, as we'd expect. And then we've got n equals 1, 2, 3, and 4. I'm not going to labour this and go through all of these. I'm just going to arbitrarily choose n equals 3, and that will give me my fourth root. So I'm going to call that z3, which is basically z0, z1, z2. So I'm going for the fourth root, z3, and that's going to be equal to 2 lots of 3 pi upon 5. Oh, wow, can't believe I just did that. Okay, cos 2 lots of 3 pi upon 5 plus I sine 2 lots of 3 pi upon 5. So we end up with cos 6 pi upon 5 plus I sine 6 pi upon 5. Okay, well, there's going to be a slight problem with this, of course, because ordinarily our value of theta, our argument, is in fact between negative pi, not inclusive, and pi. So if we are rotating anti-clockwise, it's between 0 and pi, and if we're rotating clockwise, it's between 0 and negative pi. So in actual fact, we're having to adjust this to become within our two limits, negative pi and pi. So to do that, we're simply going to subtract this from 2 pi. So let's go over here and say theta is equal to 2 pi minus 6 pi upon 5. So we can obviously change the denominator here, so that'd be 10 pi minus 6 pi, which is going to be 4 pi upon 5. And actually it's going to be a negative value. So Z3 is cos, because we're rotating clockwise, negative 4 pi upon 5 plus I sine negative 4 pi upon 5. So this is our fifth root of unity for z to the 5 equals 1. All right, thank you.
So as you can see, we've created a regular pentagon from the 5 fifth roots of unity. We've got z1 at the top, and that is equal to cos, well, what we have here is actually 1.26 in decimal form. It's actually 2 pi upon 5 because there's 5 fifth roots. So that's cos 2 pi upon 5 plus I sine 2 pi upon 5. And a typical question would be to calculate the exact area, or the area of the polygon. So what we can basically do is split it up into 5 triangles. Okay, now we know that that triangle we can find by using the basic relationship of half AB sine C. Okay, and A and B are both the moduli of, in this case, Z0 from the origin to 1. That's our first root of unity, and from 0 to Z1. So we both know that those moduli are, so moduli of Z1 is equal to the modulus of Z0, which we know is actually unity, or 1. Okay, so the area of our triangle simply becomes a half times 1 squared. I'm just going to write that down, multiplied by sine of 2 pi upon 5. Okay, that's the area of one triangle. So in fact the area of all the triangles, so the polygon area, we're going to call that P subscript A, polygon area. Actually no, we'll do that the other way around. We'll do the area A subscript P, area of the polygon, is equal to 5 lots of that. So it's 5 over 2 multiplied by 1 squared times. Now sine 2 pi upon 5 is not an exact value, but we can write down to 3 significant figures, 0.306, 306, and we can get our value of the polygon area by multiplying 0.306 by 5 and dividing by 2, and we end up with a value of 0.765 square units. Okay, squared. So that's a fairly typical question, or rather the part of a fairly typical de Moivre's theorem question, finding the area of the polygon made by the nth roots of unity. Okay, thank you.